we're the small-scale Greek yogurt production group. My name is Nikki Ciazulo.
I'm Farah Iqbal.
I'm Lauren Green.
And I'm Amanda Krager.
So our project was to take there's a local Greek yogurt company in town. They want to expand and maybe sell in local marketplaces, different like grocery stores and things like that. So our project was to take their current yogurt production that they do at their restaurant and expand it, scale it up to be able to make more yogurt and sell it and package it and be able to make more money off of it. So we ran some experiments just at the beginning. We ran fermentations at different temperatures, and we also tested the rheological properties of the Greek yogurt afterwards.
So we examined several alternative designs looking at what would be most economical for a small business, because we didn't want a large startup cost since they are a small business. And ultimately we decided on this case 2 down here, having a jacketed vessel for pasteurization and cooling, homogenization, fermentation in a tank, and then packaging and cooling, which you can see up here in our unit operation diagram. So we heat the yogurt to 60 degrees for homogenization, we homogenize it, we then heat again to 100 degrees to pasteurize, cool to the fermentation temperature, ferment for 8 hours, fill the yogurt into cups, and then cool it in a large refrigeration system.
So this is an example of what the physical plant layout might look like, and this is just doing 5 batches a week with only 2 workers at this point. And if they choose to scale up, if their business takes off and they can sell more, we have the option to add a second fermentation tank. So if they would actually scale up and build a separate facility, this is what it might be like.
Right, so for the economic analysis, from our plant design, we picked each piece of equipment and design an optimal size. And from there we could calculate the equipment cost by capacity for each vessel. So our homogenizer, our jacketed vessel, the fermentation tank, packaging and filling, the cooling, and the whole storage tank. So we get our total equipment purchase cost of about $15,000. And from there we can calculate our capital investment, our product costs, which also includes electricity, labor costs, utilities, etc. And from there we can find that our return on investment in the first year is 17%. And next we have
Some sustainability issues to look at for Greek yogurt production. A lot of companies have way toxic byproduct, which is hard to dispose of because it's not very good for the environment. And that happens because they strain the yogurt to increase the protein content of Greek yogurt, which is a characteristic quality of it when you buy it. So this process actually doesn't do that, so it's proven to be, might be more sustainable and competitive in coming years. And a lot of large corporations add milk protein concentrates to make it thicker and increase the protein. And there have been a couple lawsuits over that, but again, this process doesn't do that. It's a very basic family recipe using whole milk. So these are just some issues to look at in the market and why our products would be competitive with those.
So can you tell me a bit about the biological process of making yogurt?
Sure. To make yogurt, we start off with whole milk, and to that we add bacterial cultures. And the bacterial culture, we can choose which one we want depending on the type of taste profile we need. So the bacterial culture converts the lactose that is present in milk to lactic acid, which gives us that mild, tangy flavor that we like. And it's a fermentation process, so it takes about 8 hours. For our process, it takes about 8 hours.